We're certainly not going to go into all the gory details of analyzing randomized controlled trials. That's a topic for its own website and its own course. But we could look at strategies for analyzing randomized controlled trials in general terms. So in this type of analysis, we usually come across terms such as intention to treat, compliance corrected, or per protocol. Intention to treat tries to convey the idea that we want to estimate the effect of a allocation on disease or outcome. So what intention to treat tries to do is to estimate what is the effect of randomization on the outcome, because that's unconfounded. We know that. This is sometimes a little bit hard pill to swallow, so to speak, because we're actually not estimating the effect of treatment on the outcome. We're estimating the effect of access to treatment. I tell somebody you're in the intervention group, here's an app, versus you're in the control group, go to your primary healthcare clinic. I'm not forcing them to use the app or forcing them to go to the primary healthcare clinic. I'm giving them access. I'm allocating them. So in an intention to treat analysis, you're analyzing the effect of allocation on the outcome. Sometimes, or very often I should say, you read in papers and it gets a little bit mixed up in the language where you say, well, the intervention had an effect or the treatment increased, etc., etc. But in fact, it's the allocation to treatment that has had an effect. It's not the treatment itself. Sometimes these overlap. So perhaps surgery, vaccines, and so on. Being allocated means that you immediately receive treatment in full, and so you can't be non-compliant, so to speak. But if you get somebody allocated to a prescription of pills and they don't actually take all the pills as intended, then that's nothing you can do anything about, and you're therefore estimating the effect of allocation on the outcome. You could do a compliance corrected analysis where you say, well, I want to take into consideration the treatment they actually received. But that's an observational study. That's going to be confounded, and now you need a causal diagram to figure out how to close all the backdoor paths. Because actually taking treatment is going to be based on preference, and preference causes confounding. And there's protocol, which essentially means that you just disregard all the people who didn't fulfill the criteria that you set to start with, that they didn't actually stick to the regimen that you wanted. They maybe didn't respond to follow-up, so you remove them and so on. In a randomized controlled trial, the intention to treat analysis actually responds or tries to answer a quite different question than these two. Intention to treat should be your primary. That's why you did a randomized controlled trial in the first place. You wanted to have an unconfounded causal estimate of allocation to treatment. And so that should be your primary analysis plan to do intention to treat. But make sure you define what you mean. Unfortunately, and I say very much unfortunately, these three, intention to treat, compliance corrected, and per protocol, don't really have a unanimous agreement on what they mean. I'm going to talk a little bit about the spirit later on here for the next section, but it is a guidance for designing protocols for clinical trials, the spirit guidance. And they say, and this is, you should follow spirit, it's a good thing. They say, the ambiguous use of labels such as intention to treat or per protocol should be avoided unless they are fully defined in the protocol. Most analyses labeled as intention to treat do not actually adhere to its definition because of missing data or exclusion of participants who do not meet certain post-randomization criteria, and so on. The point is, intention to treat could mean different things to different individuals. So in your protocol, it's a good idea perhaps to mention intention to treat, but only if you fully define what you mean. And when I say fully define what you mean, in principle, you should be very clear that you're going to use allocation as treatment. That is, you're going to analyze the effect of allocation on the outcome. You're going to include everyone in the analysis that were randomized. You're not going to remove participants after they've been randomized. And you should have a plan for missing data. And I guess this is the part that has a lot of variation. These are pretty much rock solid. There's one way of doing it. Either you include all of them or you don't. Either you use allocation as treatment or you don't. But plan for missing data could be very different. There are a lot of different strategies. There are, as many strategies for missing data, there are strategies for modeling your outcome or modeling your analysis. You can calculate risk ratios, prevalence proportions, you can calculate confidence intervals, and so on. All of these are readily available and unconfounded because you randomized. You can draw survival curves and compare. You can use regression models if you want to adjust for variables to reduce variance, or if there are slight differences at baseline, you could use adjustments for that. You could use group by time coefficients if you want to analyze differences across time. You can use interactions or multi-level models if you think there's heterogeneity, etc., etc., etc. There are lots of different models to pick from. You should pre-specify how you're going to analyze your data, and you should consult hopefully good data analyst. This is a job in itself, so make sure you consult somebody that's used to doing this type of modeling that you want to do and can help you with it. In your limitations, you should raise potential sources of bias. You should balance your results with potential bias. You should think about what your model tells you, add in what bias you expect in your study, and see what are actually your findings. And also consider if you actually can account for the bias in analysis. So not just raising it as a concern, but actually accounting for it. And there's a paper here on one way of doing it using causal models. There are obviously a lot of do nots in analysis. There always are. But there's one thing that I see quite often that I think is worth just pointing out here. And that is, do not calculate change scores. That is follow-up minus baseline. As tempting as that might be, randomized controlled trials are designed to compare across groups, not within groups. And there's a very good paper written by Vickers and Altman who describes why this is an issue and what you should do instead. Basically, the answer is you should adjust for baseline values. Do not calculate change scores by taking follow-up minus baseline. This is worth reading. There's a link here.